Okay, in today's lecture we start with Valence Bond Theory. Before we directly jump into VBT or Valence Bond Theory, let's quickly go through what were the drawbacks of Lewis Octet Theory. The first drawback of Lewis Octet Theory was Lewis Octet Theory couldn't explain hypervalent compounds. What were hypervalent compounds? Compounds which have more than 8 electrons in their outermost shell. Second drawback क्या था? Lewis theory couldn't explain hypovalent, incomplete octet compounds को explain नहीं कर सकते थे, which is compounds containing less than 8 electrons. What was the third drawback? It couldn't explain noble gas compounds XeF2, XeF4. Fourth drawback, couldn't explain energy, stability and shape of molecules. Now, in order to overcome these limitations of octet theory, the next theory that we are going to study, people, is called as Valence Bond Theory. Now, I've written some important points Valence Bond Theory ke. So, to explain the nature of covalent bonding, okay, quantum mechanics gave us two theories. First theory जो आज करने वाले हैं, which is called as VBT, Valence Bond Theory. Valence Bond Theory को आगे हम थोड़ा सा और improvise करते हैं with hybridization and further improvisation using something called as valence shell electron pair repulsion theory. इन तीनों को हम gradual progression में we will study. तो VBT के बाद आएगा next concept of hybridization. Hybridization के बाद next concept आएगा which is called as valence shell electron pair repulsion theory, VSEPR. और ये पूरा होने के बाद we are going to study something called as molecular orbital theory, MOT, or molecular orbital theory. Now let's understand what is VBT trying to explain. VBT क्या बोलता है? VBT says that एक कोवेलेंट बॉन्ड बनने के लिए we need atomic orbitals. So let's say ये एक atomic orbital है for hydrogen atom, hydrogen, atomic number 1, configuration 1s1. तो we know that ये हमारे पास 1s and इस 1s में I will have one electron, let's say जिसको हम बोल रहे हैं I have a electron with a clockwise spin, and we know that s orbital, ठीक है, directionless होते हैं, but let's say this is x axis, ये हो गया let's say y axis और ये आपकी z axis, but s orbital are directionless, but हमने फिर भी यहाँ पे थोड़ा axis बना के रखा है. And you'll have एक और हाइड्रोजन एटम, सेम कॉन्फ़िगरेशन 1s1, बट यहाँ पे हमारे पास एक इलेक्ट्रॉन है विच इज इन एंटी क्लॉकवाइज. सो वी नीड टू एटम्स जिनके इलेक्ट्रॉन स्पिन्स आर ऑपोजिट, एंड these two atoms will approach each other. ये जो atomic orbitals हैं, they approach each other along the same axis. So the two orbitals, they come close to each other along the same axis and they tend to overlap. To form a covalent bond, overlapping occurs between half-filled valence shell orbitals of two atoms and resulting bond formation takes place. So I repeat, what's happening here is these two orbitals, they're coming close to each other and they will overlap, and this you can say is that resulting overlap and bond formation. So the electron density is now in between the nuclei of the two hydrogen atoms. So जो आपका ये shared pair of electrons है ये यहाँ पे present है in this shaded region, and this phenomena is the overlapping of orbitals. So orbitals, they come close to each other from the direction where there is a possibility of maximum overlap. I repeat, so ऐसे नहीं है कि अगर एक orbital x axis की तरफ से आ रहा है, the other will come along y axis. No, they will try to come along the same axis to overlap. And जितना ज़्यादा overlap, which is common sense, उतना ही ज़्यादा strength of bond formation. When these orbitals overlap, or the overlapping of orbitals result in the formation of two types of covalent bonds. And the two types of covalent bonds are called as, first, sigma bond. Okay, this is read as sigma bond. And the second type is called as pi bond. There's another type, ठीक है, जो थोड़ा सा एक्स्ट्रा है. This is called as a delta bond. Our major focus will be on the first two types of bonds. इनमें ही हमारा major focus होगा. But I will also give you a small overview as to what is a delta bond. So remember, orbitals, they come close to each other, they overlap, and they form covalent bonds. जितना ज़्यादा overlap, उतना ही stronger the bond, because उतना ही distance between the nuclei is small. Smaller the distance between the nuclei, stronger will be the overlapping. So the first type of overlap, पिछले पेज पे हमने कर दिया था, but let's do that again. The first type of overlap that we have is called as SS overlap. Now, as the name suggests, SS overlap means when two s orbitals are overlapping each other. तो ये हमारे पास फर्स्ट s ऑर्बिटल. रिमेंबर, इसमें एक इलेक्ट्रॉन होगा विथ वन स्पिन, इसमें एक और इलेक्ट्रॉन होगा विथ अ स्पिन, बट दैट स्पिन हैज टू बी ऑपोजिट. लेट्स से दिस इज x एक्सिस, दिस इज y एक्सिस. मैं z बना नहीं रहा हूं. x एक्सिस, y एक्सिस, they come close to each other and overlapping takes place. This overlapping is called as SS overlap. This SS overlap results in the formation of the first type of covalent bond, which is called as sigma bond or a sigma covalent bond. Now ये हमने, so this could explain the formation of H2 molecule. मतलब मेरे पास ये एक हाइड्रोजन एटम है, एटॉमिक नंबर 1, इलेक्ट्रॉनिक कॉन्फ़िगरेशन 1s1. ये भी एक हाइड्रोजन एटम है, एटॉमिक नंबर 1, इलेक्ट्रॉनिक कॉन्फ़िगरेशन 1s1. एंड यहाँ पे हमें क्या मिल गया पीपल? H2 molecule. It is as simple as that. Now, if I compare the extent of overlap, इसका मतलब, let's say I compare 1s and 1s overlap with 2s and 2s overlap. Obviously, जैसे 2s का size is bigger than 1s, the distance between the nuclei will increase. As the distance between the nuclei increases, bond length will actually increase, and hence strength of bond decreases. In short, एक sigma bond between 1s 1s is stronger than a sigma bond between 2s 2s. which is stronger than a sigma bond between 3s and 3s and so on. Did you get that? So as the size of the orbital increases, obviously the extent of overlap will decrease, and as the extent of overlap will decrease, bond length will increase, and as bond length increases, bond strength decreases. So I'll write it over here. Bond strength is inversely proportional to bond length. This is called as SS overlap. Now the second type of overlap that we have is between the s orbital and p orbital. इसको हम बोलते हैं s p overlap. What's the shape of the s orbital? Spherical. p orbital की shape क्या है people? ये हो गया आपका s orbital, and the shape of the p orbital is dumbbell shaped. Now over here the axis of approach is important because p orbital is directional in nature. मतलब यहाँ पे जो मैंने बनाया है, this is px, so this is x-axis, and hence your s orbital should come close to the px orbital, and this also should be along the x-axis. So उन दोनों का approach should be along the x-axis, and hence when sp overlapping is taking place, I repeat, when sp overlap is taking place, the overlap has to be along the axis. Both the orbitals have to come close to each other along the axis. It's only then that they can overlap. ये overlap तभी possible है when both come along the same axis. ये overlap ऐसे possible नहीं है. This is, let's say, along y-axis, और मैंने क्या बना दिया यहाँ पे? This is not possible. So when they come close to each other, ये आपका S है, overlapping with the p orbital, and यहाँ पे is the maximum density of the electron. This results in the formation of sigma bond, और इसको हम क्या बोलते हैं people? S P overlap. Now if you observe, one of the lobes is smaller in size. The reason for that lobe being smaller in size is maximum electron density is over here. So the probability to find the electron in that side of the lobe is actually 0. इसलिए वो lobe का size छोटा हो जाता है. Did you people get that? इसको हम बोलते हैं SP overlap. And remember, this overlap is directional in nature. अब सेम जो यहाँ पे, this would look something like this. अगर हम overlap करने जाए. Getting that? And this is not possible. ऐसा overlap does not take place. Okay. So this overlapping is not possible, और इसको हम बोलते हैं SP overlap. Now sp overlap helps us understand the formation of molecules such as hydrogen fluoride. इसमें first is hydrogen, atomic number 1, electronic configuration क्या people, and fluorine atomic number 9, electronic configuration, last shell में 2s2 2p5, so 2s has 2 electrons. So यहाँ पे आपका एक अनपेयर्ड इलेक्ट्रॉन है एंड यहाँ पे ये हाइड्रोजन का एक अनपेयर्ड इलेक्ट्रॉन है. रिमेंबर फॉर देम टू ओवरलैप दोनों का स्पिन शुड बी ऑपोजिट. सो हाइड्रोजन का 1s एंड यहाँ पे लेट्स से दिस इज, इफ आई से ये है 2px और लेट्स से ये है 2py और लेट अस अज्यूम ये है 2pz. So this s orbital has to come along which axis? Z axis. And यहाँ पे हमारे पास कौन आएगा? फ्लोरीन का 2pz. They come close to each other and same ऐसे overlap बन जाता है, sp overlap. So the final overlap structure कुछ ऐसे दिखेगा वो. और यहाँ पे आपके वो इलेक्ट्रॉन्स हैं. This explains the formation of hydrogen fluoride. Did you people get that? So first overlap was SS overlap. The second overlap is called as SP overlap. And when you compare strength, it is exactly the same. Strength का मतलब 1s and 2p overlap will be stronger than, because 1s 1p तो नहीं हो सकता, so 1s 2p is stronger than 2s 2p, which will be stronger than next overlap. क्या possible है people? 3s 3p, which will be stronger than 4s 4p, so on and so forth. In short, अगर हम SS या SP ओवरलैप की बात करें, प्रिंसिपल क्वांटम नंबर 11 वाले ओवरलैप is stronger than principal quantum number वाले 22 overlap and is stronger than principal quantum number वाले 33 overlap and is stronger than principal quantum number वाले 44 overlap and so on and so forth. Did you people get that? Any questions over here? Now, if I want to compare the strength of SS overlap and SP overlap, दोनों में से कौन ज्यादा स्ट्रॉन्ग होगा? SS overlap स्ट्रॉन्ग है या SP overlap स्ट्रॉन्ग है? SP overlap is stronger than SS overlap. The reason for this is SP overlap is a directional overlap and SS overlap में direction matter नहीं करता. इसके बाद there is one more overlap, तो तीनों को हम साथ में compare करेंगे in terms of their strength. So SS SP, the next type of overlap, this will also give you sigma bond. The next type of overlap that we have is called as PP overlap. Again, PP overlap is also directional in nature. So हमारे पास है let's say इसको we take it as PX, so it's along the x axis. We need one more px orbital. Both the px orbital will overlap along the axis. या इसको हम एक और नाम दे सकते हैं. This is called as head-on overlap. which results in the formation of यहाँ पे आपके इलेक्ट्रॉन आएंगे, that's your sigma bond, and this is called as PP overlap. Again, remember this, PP overlap is also directional in nature. Now when you compare the strength, if you compare the strength of overlapping, PP overlap is stronger than SP overlap, which is stronger than SS overlap. This is the strength of the overlapping. Why? Because most directional, maximum amount of overlapping, and hence maximum strength. यहाँ पे this is non-directional, and hence smaller the amount of overlap, and hence weaker the bond. Now, these are the different ways of formation of sigma bonds. We'll go back to what exactly is a sigma bond, या जो हमने covalent bond पढ़ा था. So covalent bond is formed by which are the different types of overlaps? SS overlapping, SP overlapping, and PP overlapping. Now there are few more points जो हम थोड़ा सा later or in the chapter समझते, but I'll still give you those points. Sigma bond does not participate in resonance. And rotation takes place along sigma bond only. What these 2 points mean, थोड़ा सा हमें बाद में पता चलेगा. But resonance is, I'll still give you a small overview. हमने देखा there are certain molecules which have multiple Lewis structure. वो multiple Lewis structure is a result of resonance. And when we say rotation takes place, along a sigma bond, so if you imagine that this is the sigma bond or single bond, a single bond is constantly rotating by taking energy from the environment. This is called as rotation of a sigma bond, which results in the formation of what are called as conformers, जो हम organic chemistry में पढ़ते हैं. Now this is formation of sigma bond. एक और point है, but वो हम pi bond बनने के बाद लिखेंगे. So the second type of covalent bond that we have is called as pi bond. And pi bond formation कैसे होता है? Let's say this is my py orbital. I repeat, this is my py orbital. So I have 2 of these. Now these 2 py orbitals, they are along y-axis, but they are approaching each other along x-axis. I repeat, they are along y, but they are approaching each other along x-axis. I repeat, this was along the axis overlap, so दोनों coming along the axis. यहाँ पे they are coming like this, sidewise overlapping. or this is called as lateral overlap. So when the two are overlapping sidewise, such a bond is called as a pi bond. Remember, electron is a wave, so it can be present either in the plane above the axis or in the plane below the axis. So इसको आप ऐसे भी बना सकते हैं. I repeat, the electron can be present above the axis or it can be present below the axis. So sidewise or lateral overlapping results in the formation of what is called as a pi bond. Now since the extent of overlapping is less, sigma bonds is stronger than a pi bond. I repeat, यहाँ पे the extent of overlapping is less than sigma bond. Since the extent of overlapping is less than a sigma bond, a pi bond is weaker. Now, between two atoms, there can only be one sigma bond. If an atom wants to form another bond with the same atom, the second bond becomes a pi bond. Let us try and understand that. इसका मतलब क्या है? I want to understand the formation of O2 molecule. हमने O2 का लुईस स्ट्रक्चर बनाया. O2 का लुईस स्ट्रक्चर कुछ ऐसे था. This was the Lewis structure of O2. Now let us understand ये O2 का Lewis structure से how does VBT explain the formation of O2? Oxygen atomic number 8, last shell configuration is 2s2 2p4. So 2s में कितना इलेक्ट्रॉन है? 2 electrons in 2s and 2p has 4 electrons, so 1 2 3 and 4. How many electrons each oxygen needs to complete its octet? 2. So this is, let's say इसको मैं बोलता हूँ 2px, इसको मैं बोलता हूँ 2py और इसको मैं क्या बोलता हूँ 2pz. Now remember, there are two oxygen atoms. So let's say ये first वाला oxygen atom है, इसके साथ एक और oxygen atom आएगा. This is the second oxygen atom. ठीक है, just for representation इसको मैं बोल रहा हूँ first oxygen atom, इसको मैं बोल रहा हूँ second oxygen atom. This is first oxygen atom का 2px, तो इसको बोलते हैं 2px1 y1 z1. इसको बोलते हैं 2px2 2py2 2pz2. I repeat, this is just for understanding. ये first oxygen का 2s2 या 2s12, इसको मैं बोलता हूँ 2s2. I repeat, both the oxygen atoms need 2 electrons each to complete its octet. तो first oxygen क्या बोलता है? ये मेरा 2py है. I repeat, this is the first oxygen का 2py of the first oxygen. इसमें एक इलेक्ट्रॉन है. अब ये जो दूसरा इलेक्ट्रॉन है, it has to be of the opposite spin. Remember, मैंने सेम स्पिन बना दिया बट सेम नहीं होना चाहिए, वो ऑपोजिट स्पिन. ये है सेकेंड इलेक्ट्रॉन का 2py, सेकेंड ऑक्सीजन का. सो दे हैव मेड द फर्स्ट बॉन्ड. ये जो ऊपर का सिग्मा बॉन्ड है वो ये है. This is oxygen, first oxygen का nuclei, this is second oxygen का nuclei. So दोनों के बीच में, that's the first bond. Now understand this. Overlapping has taken place along which axis? Both the overlapping has taken place along the y-axis. Up next overlap has to take place along which axis? Z-axis. So Z-axis ये 2p Z1 और ये सेकेंड ऑक्सीजन का these will overlap sidewise and they form a, so the second bond here is pi bond. So in short, if let's say this was the first bond, ये 2py और ये 2py ये साइड से ओवरलैप हुए, then how did 2pz overlap? This was 2pz of one oxygen, this was 2pz of the second oxygen, and they've overlapped sidewise. Of course on a two-dimensional board 3D structure नहीं बना सकते वो, but उन दोनों का electron cloud is overlapping each other. So ऐसे imagine करो यहाँ पे एक balloon है और यहाँ पे एक balloon है, and the two are sharing electrons. वो कुछ ऐसे दिखेगा. ये वो overlapping है, but वो यहाँ पे हम नहीं बता सकते because two-dimensional board है. Now where did these two lone pairs come from? 1, 2, 3, 4. ये हैं. ये जो दो lone pairs दिख रहे हैं 2s and 2px, these lone pair they come from here. This is how VBT explains the formation of O2 molecule. So now wherever you see a double bond, in a double bond there is one sigma and there is one pi. If the same way I want to understand the formation of N2 molecule, where nitrogen has a triple bond with one more nitrogen. Nitrogen, atomic number 7, last shell configuration is 2s2, 2p3. So 2s has 2 electrons and 2p has 3 electrons. Remember, ये आपका 2px, 2py and here one more nitrogen will come. The second nitrogen needs 3 electrons to complete its octet. The first nitrogen needs 3 electrons to complete its octet. The first nitrogen का 2p will overlap with the second nitrogen का 2p and बन गया आपका पहला sigma bond. So first overlap took place like this. How will the second overlap take place? 2py and 2py. Third overlap कैसे होगा? 2pz and 2pz. I repeat, first overlap is second overlap x 2py and 2py, and third overlap is 2pz and 2pz. Did you people get that? Yes or no? Pi bond, pardon me, sigma bond, and the other two are pi bond. You get the message, the concept. ठीक है? So I repeat, a two-dimensional board पे थोड़ा we'll still try to make it. ये आपका 2px था, which overlapped with 2px. This is 2py which overlapped with 2py और कौन सा बॉन्ड बना and 2pz और z axis is coming towards it's coming out of the board वो आपकी तरफ आ रहा है I cannot make that on a two dimensional board but उसको थोड़ा ऐसे बनाता हूँ this is 2pz and 2pz again lateral sidewise overlap so in a triple bond there is one sigma and बाकी के दो are pi bonds. A double bond has one sigma, one pi. A triple bond has two sigma and one sigma and two pi. Did you people get that? So the first pi bond formation takes place between So PP overlap sidewise will give you first pi bond. The second type of pi bond formation is क्या नंबर दिया था third this is 3a this is 3b now next we have this is again py and this is x-axis. Next है हमारे पास this is d-orbital. You can consider let's say this to be as like dxy. Again sidewise overlapping. This is called as P, which is overlapping with D and forming pi bond. इसको हम बोलते हैं P pi D pi overlap. This can be also called as यहाँ पे मैं लिखना भूल गया P pi overlap. This is called as P pi D pi overlap, and the last pi bond formation is this is d orbital, one more d orbital, overlapping sidewise, this will be called as d pi overlap. So pi bond formation takes place between p pi and d pi, and then finally d pi overlap. When we do hybridization, तो हमें बताना है in certain molecules if there are pi bonds, the pi bonds are formed by which kind of overlap? Are they formed between p pi overlap, or are they formed by p pi d pi overlap, or they formed by d pi overlap? You'll have to find number of pi bonds, किसका क्या orientation से bonding हुआ है. ठीक है? Now, if I compare the strength of pi bonds, I repeat, if I compare the strength of pi bond formation, so the strongest pi bond is between 2 p pi and 2 p pi. Then it is between 2 p pi and 3 d pi. Then it is between 2 p pi and 3 p pi. Then it is between 3 p pi and 3 p pi, and then वो cycle को repeat करो, 2 p pi, 2 p pi, 3 p pi, and then you can continue the cycle as 3 p pi and 3 d pi, and so on and so forth. कर सकता है वो cycle repeat, because 3 p pi can also overlap with 3 d pi. Then इसके next पे कौन आएगा people? 3 d pi with 3 d pi. So on and so forth. The reason 2 p pi 3 d pi is a bit stronger than 2 p pi and 3 p pi is because 3 d pi has थोड़ा सा inclined character, and because of that inclined character, overlapping is a bit more stronger as compared to 2 p pi and 3 p pi. And the last type of overlap, which results in the formation of delta bonds. Delta bonds हम इतना in depth नहीं पढ़ते, though I'll still give you an overview when we do coordination compounds. Delta bond में, and on a two-dimensional board वो थोड़ा सा tricky भी होगा to understand. So let's say I have d orbital and I have another d orbital. So the overlap that is taking place is this with this, नीचे का lobe और ये नीचे का lobe, the lobe on the left with the lobe on the left, and the lobe on the right with the lobe on the right. Can you imagine something like this? Let's say this is the first d orbital, ठीक है, and let's say this is the second d orbital. d pi ऐसे बनाया था, okay, but the delta bond formation takes place like this. So ये जो ऊपर वाले lobes है, they are overlapping, these sidewise lobes are overlapping, and these lobes are overlapping. I repeat, this was d pi overlap, but the delta bond formation ऐसे होता है. Did you people get that? That is delta bond. Delta bond is the weakest of the three. So sigma, अगर सबकी strength हम compare करें, so the first is sigma bond, then we have pi bond, and the next we have delta bond. Okay, now Sigma bond does not participate in resonance, but pi bond or pi electrons actually participate in resonance. Rotation takes place along sigma bond, no rotation along pi bond. And sigma bond is stronger than pi. Did you people get that? Now this completes the first part of valence bond theory. Using VBT, we need to understand the formation of methane molecule and drawbacks of VBT. We'll complete that in the next part of VBT का lecture. ठीक है? Thank you everyone.